Good afternoon, Scott here, known as Cantaloupe to some online, and I'm bringing another subject to you that's interesting to me. It might be of interest to you or someone you know, and that is best practices in programming. This is going to be kind of a technical video because I do a lot of programming myself. With my background includes some formal education and a lot of hands-on experience and professional experience as well. But the point here is that there are best practices that a lot of people, and especially newer programmers, lean on, and they preach them with absolute certainty that there's no cases in which bad practices should ever come into play. And I'm going to give some examples. There's something called a race condition in programming where two processes are racing to complete, and while it may sometimes work given a particular set of circumstances, it's generally viewed as bad practice because those circumstances are subject to change. And it's not so much the fact that it could possibly fail, it's called a bad design pattern, and it's recommended strongly against by anyone who really knows what they're talking about in programming. So here's the thing though, to say never means, usually it means never, but never is not the proper answer in this case. And I don't mean just for production, because production is, when you're finished with a project, it's rolled out for end user service. It can be used by anybody. It's ready for the marketplace or whatever. In any case, race conditions can be very useful for things like problem solving, and that's kind of my point. Like a lot of bad practices, whatever gets you to the understanding of the problem is not bad practice. And I actually ran into this today. It's interesting. So my point in this video is that never say never, I guess, but with specific emphasis on using whatever tools are helpful to understand a problem as quickly as possible, right? Even if your intention is to back up afterwards and roll it out properly. This is a valid pattern. It's a valid design pattern, but a lot of people don't understand that, unfortunately. A lot of people are, obsessed with the best practices that they hear about or learn in school and refuse under any circumstances to try anything unconventional or that was not specifically taught or recommended. So let me give you an example, a better example. Consider you have a bug in your code, right? If you're a software developer and you've got a nasty bug or a difficult, stubborn bug, and you spend, some hours or days on it, and you still haven't discovered what's causing it. This can happen. Hopefully it's rare, especially if you're experienced, but it can happen to any programmer. So at some point, you're going to want to probably roll out the unconventional testing just to eliminate the remote possibility that it's something else, something that you haven't been looking at directly, or that cannot necessarily be discovered with best practices. And this might involve creating race conditions, for example, intentionally, and then pinpointing what is causing the bug with those race conditions, with the expectation that you'll delete them before moving on, before putting your program out into production. So just something to think about, that for testing and science purposes, there are no best practices except for what works, whatever works. And that's largely a point of computer science or any kind of science where you enter without assumptions. Science, almost by definition, requires objectivity. I think that that's a core concept. And when you come in with prior beliefs, prior conclusions or assumptions, that's not science. That's something else. That's being biased, and it will blind you to possibilities eventually. Maybe not right away, maybe not once or twice, but eventually you'll run into something that cannot be resolved because you're refusing to look at certain possibilities. So anyway, maybe a drier video, but if it's interesting to you, great. Reach out with questions or comments to whitehotrobot@gmail.com. Thank you.